All right, class, so we're finally done talking about naming. Now, what are we going to do today? We're just going to do practice problems. That's all we're going to do, just practice problem. So, we said that before you do naming, you're going to have a periodic table in front of you, right? The first thing we're going to do, we're going to label this periodic table. We said group 1A, they're plus 1 because they lose 1 electron. Group 2A, plus 2, 3A, plus 3. We said halogens, they would gain 1, oxygen group minus 2, nitrogen group minus 3. Again, all of these atoms on the periodic table, the way they are neutral. But to form an ionic compound, they have to lose or gain electron in order to form an ionic compound. You have to give up something to make an ionic compound. So then these are the charges that they would have when they form an ionic compound. So far so good. Metals always 1, 2 lose, non-metals 1A gain. And then we said that this 4A group, they don't really like to form ionic compound. But the two that you also have to know in that group is tin and lead. And we said those two could be plus 2 or plus 4. They have two possible charges. And we also said if you have more than one possible charge, then you always have to use Roman numeral to indicate which one you're talking about. So far so good. Then we said the transition metal. Those are a hot mess. Many of these metals in the transition metals have more than one possible charge. Many of them have many charges. There are two transition metals that have a fixed charge. That is zinc has a plus 2 charge and silver has a plus 1 charge. The rest, they have many possible charges. Now what are we going to do? So what I want you to do, I want you to know that silver is always plus 1, zinc is always plus 2. And the rest of them, they have a lot of different charges. And you don't have to worry about it because in a question, I would have to somehow tell you which one I'm talking about. And the rest of them would also get a Roman numeral because they have more than one possible charge. So far so good? Okay, so again, this is for ionic compound, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Tin and Pb could be plus 2 or plus 4. Zinc is plus 2 all the time. Silver is plus 1. And the rest, I have to kind of tell you what the charge is. And every time, the ones in the transition metal and tin and lead, because they have more than one possible charge, they have to get a Roman numeral. All right. The other thing you have in front of you is this one right here, polyatomic ion. If you are in Chem 30A, you do not have to memorize this. You can have this on the exam. If you're in Chem 1A, you have to memorize this. Okay? Now, hopefully you have some appreciation for it. I told you guys a lot of these polyatomic ion, you use it on a daily basis. Read any labels. I promise you, if you read a label, shampoo, soap, energy drinks, you will find some of these polyatomic ions in there. One of them that I didn't talk about, I don't know why I didn't talk about them, was carbonate. Every time you have a carbonated drink, think about this. It has a CO3 minus 2 in it. So a lot of these things you actually use on a daily basis. So here are polyatomic ions, and all I really want you to do right now, just be able to recognize a polyatomic ion when you see it. Now, we said we have 4 types of compound. The first type is ionic, and ionic is when you have a metal and a non-metal. Again, this is all review, but let's review. And when you have an ionic compound, is a metal or a non-metal, and metal is cation, non-metal is anion. And what you have to do, you have to balance charges. Now, covalent compound, we said covalent compound is 2 non-metal. And because they both want to gain, there is no balancing of charges. What do? They share electrons. There are no balancing charges. There is no balancing charges. I need you to remember that. There is no balancing of charges. Now, how do you know you have an acid? Acid starts with H, and then you would have an anion. How would you know you have a base? Base ends with OH, and you have a cation. So acid is going to start with H, base is going to end with OH. And both acid and base, you can treat them like ionic compound. You have to balance charges. You have to balance charges for acid and bases. So far so good? Okay, and I gave you the rules for naming acid. And for covalent compound, because it's a sharing of electron and there's no charges, you have to use prefixes, right? You have to use prefixes for those. So this is kind of like an overview of what we talked about. Now let's get to the practice problem. All right, pause me, do this, and then check your answer with me. Manganese 2 chlorate, okay? First of all, what is the formula for manganese? Manganese is Mn, and I'm telling you is manganese 2. And why am I telling you is manganese 2? The reason that I'm telling you is manganese 2 because manganese is a transition metal. I have to tell you, silver and zinc are the only transition metal that have a fixed charge. The rest, I have to tell you what the charge is because they have many, many different charges. Chlorate. Now, every time you see 8 or 8, what are you going to think about? You're going to say, oh, that's probably a polyatomic ion. So let's go to our polyatomic ion chart. So chlorate, here is chlorate, is ClO3, is ClO3. And the charge is -1. You can look it over there. Now, this is an ionic compound. Again, ionic compound is balancing of charges. You cross multiply the charges. If I do that, what I end up getting is MnClO3 2. MnClO3 2. That's manganese 2 chlorate. These are hard problems, but let's do hard problem to make sure you guys are getting this down. Iron 3 silicate. What's the formula for iron? Fe, and I'm telling you is iron 3. Why did I tell you? Because iron is a transition metal. They have more than one possible charge. I have to tell you which one it is. Now, this one is silicate. Again, every time you say 8 or 8, what are you going to think about? You go, oh, it's probably polyatomic ion. Let me come over here. This is silicate. SiO4, charge of -4. So now I'm going to go here. SiO4, charge of -4. So what I'm going to do, I'm going to cross multiply the charges. If I cross multiply the charges, what I end up getting is Fe4 SiO4 3. Okay. Hard questions, but hard is good. Again, I'm cross multiplying the charges to balance the charges out. And again, I put a parenthesis here because that means I need 3 SiO4. There's 2 number, I need a parenthesis. Alright, mercury 1. Go back to the notes. If you remember, we said that mercury 1 is a special case because mercury 1 doesn't want to hang out by itself. It is always hanging out with another mercury 1. So the way you write mercury 1 is Hg2 in bracket. But because you have 2 mercury 1 hanging out together, the overall charge is +2. Okay? Now, let's talk about acetate. Let's talk about acetate. Okay? Now, acetate, again, when you see 8, you're going to say, oh, that's probably a polyatomic ion. Let's come over here. Acetate. Where is the acetate? Acetate is right here. And I want you to pay attention to acetate. There are 2 ways of writing acetate. And both ways is fine. This way, they're basically the same thing. Here you have 2 carbon. Here the 2 carbons are separated, but you end up with the same exact formula. So it doesn't matter which one you want. You can use either one, And you should know that either one is acetate. Again, they're the same thing. There's 2 carbon, this is 2 carbon, 3 hydrogen, 2 oxygen, 2 oxygen. It's just a different way of people writing it. Okay, before we do that, another reason you should know polyatomic ion. Acetate. Acetate, acetic acid. That's vinegar. If you ever put vinegar as a salad dressing, it has this compound in there. It's pretty cool, right? All right. So what I'm going to put over here, I want to put the C2H3O2. Doesn't matter which one you put. And then if you remember, the charge was -1. So I'm going to cross multiply the charges. I have to cross don't do that. I have to cross multiply the charges. If I do that, what I end up getting is, again, mercury 1 and then C2H3O2 2. Because the 2 over here is going to go down here, but I have to put a bracket. So far, so good. Again, these are hard problems, but I'm trying to do the hard problems now so you guys have an easier time on the exam. Potassium phosphide. What's potassium? Potassium is K. Again, hopefully you guys are getting this down. You see 8. Every time you see 8 or 8, what are you going to be thinking about? You're going to be thinking about polyatomic ion. Let's go over here. Which one is phosphide? Phosphide is over here. PO3 minus 3. So I'm going to come back here. So phosphide is PO3. Now, potassium is group 1A. You know the charge is +1. The charge is +1 because it's group 1A. And the phosphide, we just looked at it, the charge is -3. So I'm going to cross multiply the charges. If I cross multiply the charges, I get K3PO3. K3PO3 would be potassium phosphide. Again, how did I know potassium was +1? Periodic table. Here's potassium. Is in the group +1. So far, so good? All right. Nice job. I know a lot of problems, but these are good. These are good for you. Now, next one is chloric acid. Chloric acid. Okay. Now, I'm asking you to write a formula. Now, if I have chloric acid, as soon as you see the word acid, what are you going to write down? You're going to write down a hydrogen at the beginning because acid starts with H. Now, remember the rules for acid? Okay. I'm going to remind you of the rules for acid. Here is the rule for acid. I just put it up again. Ide becomes hydroic acid. 8 becomes ic acid. 8 becomes us acid. So here I have chloric acid. Chloric acid. If I have chloric acid, I used to be 8. I used to be chlorate. So I used to be what? I used to be chlorate. Because if I'm chlorate, then I'm going to become chloric acid. Chlorate, you know that's a polyatomic ion. Let's go back to this polyatomic ion sheet. Which one is chlorate? Chlorate is ClO3 minus 1. Okay, so what I'm going to put here, ClO3. And then hydrogen has a +1 charge. Chlorate has a -1 charge. So these two are balanced out. You guys are good so far? Okay, beautiful. Because again, remember, you have to balance the charges for acid. Zinc nitride. Okay, help me out. Zinc is Zn and nitride. Again, if you are ending with ite, it's just from the periodic table. It would be nitrogen. Okay. Now remember, zinc is one of the only 2 transition metal that has a fixed charge. What's the charge of zinc? You have to notice is +2. Now nitrogen, look at the periodic table. If you look at the periodic table, it has a -3 charge. So now what I have to do, I have to cross multiply the charges. If I do, I get Zn3 N2. That's zinc nitride. Again, I know that this is nitride, ends with I. Probably that means it's a simple ion from a periodic table. Ready for next one? Sulfurous acid. Again, you see the word acid, what's the first thing you're going to do? You're going to put an H. Now, what type of acid is this? It ends with us. If you end with us, you used to be what? You used to be ite. You used to be ite, right? Again, ite is a polyatomic ion. Every time you see ate or ite, those are polyatomic ion. Make a note of that. So, if this is sulfurous, this used to be ite. That means it's sulfite. That means it's sulfite. I'm going to go back to the polyatomic ion. Where is my sulfite? My sulfite is right here. SO3 minus 2. Okay, so this is going to be an SO3 minus 2. Hydrogen has a +1 charge because it's in a 1A group on a periodic table. So I'm going to cross multiply the charges. I get H2SO3. That is my acid, sulfurous acid. Not bad, right? Not bad. And let me bring up the periodic table one more time. Just remember, hydrogen is right here, is a 1 + 1 + 1 charge, okay? All right, now gold 3 sulfide. Gold is Au. I'm telling you it has a +3 charge. Why am I telling you? Because gold is a transition metal. So I have to tell you what is the charge, because gold +1 exists, gold +3 exists. Sulfide, again, if you end with I, that means you probably came straight from the periodic table. You used to be sulfur. You used to be sulfur, right? Okay, let's go to the periodic table. Let's go to the periodic table. Sulfur is right here. What's the charge? The charge is -2. The charge is -2. Okay, so we are going to cross multiply the charges. If I do that, I get Au2S3, gold 3 sulfide. Okay, again, every time you see ate or ite, think about polyatomic ion. When you see ite, think about the periodic table. Oh, this one is good. Hydrophosphoric acid. Again, if you see the word acid, what's the first thing you're going to write down? You're going to write down hydrogen. And you go, okay, and hydrogen has a +1 charge. This one is hydro. If you have a hydroic acid, that means you used to be ide. So that means that used to be ide. This used to be phosphide. Used to be phosphide. So you are a simple ion from the periodic table. Ate and ite, think about polyatomic ion. Ide, think about this the periodic table. So hydrosulfuric acid, I'm going to put an H, is hydro. It used to be ide. So this would be phosphide. Phosphide is P, right? On a periodic table, what's the charge on phosphide? Look at the periodic table. The charge on phosphide is -3. So I'm going to cross multiply the charges. It would be H3P. That would be hydrophosphoric acid. Again, it's not a polyatomic ion because it ends with ide, right? So it's phosphide. So it's H3P. All right, almost there. Last one for this part. 10,4. 10 is Sn. I'm telling you it's a +4 charge because 10 could be +2 or +4, so I have to tell you which one it is. Oxide. Oxide means you are oxygen. Oxygen has a -2 charge. Okay, this is good. Again, when you end with ide, that's just a simple ions from the periodic table. So what I have would be SN2O4. Except what do I need to do? And you must do. I can simplify this. I can simplify by dividing it by 2. If you can simplify, you must simplify. So I can simplify by dividing by 2. If I divide by 2, I get SNO4. I get SnO4 because you must simplify if you can simplify. All right, hopefully you feel pretty good about this. Just remember, ate and ite. Think about polyatomic ion. Ite, think about the periodic table. Those are simple ions that the ending just changes to ite. All right, more practice problem. This is good. This is good. I know you're hating me right now, but you'll love me later on the exam. Now, the next part, I want you to name him. The last part, writing the formula, I want you to name him. And again, these are hard problems. 2 hard problems. Hard is good. This one is the Hg2CrO4. Okay. Now, if you look at this, every time you see mercury in bracket, what type of mercury is that? That's mercury 1, because mercury 1 is in bracket. Okay. Now, what is this one? CrO4. Does that look familiar? That's a polyatomic ion. CrO4. Can you guys find it? Oh, I can't. Okay, right here is oxalate. Chromate. CrO4 is chromate. Again, all I'm asking you to do right now, be able to recognize polyatomic ion. You go CrO4, you go, oh, that must be a polyatomic ion. Let me look at the my chart to see what is that polyatomic ion. So mercury 1 chromate. Okay. And when we're naming polyatomic ion, we don't change the naming, right, for ionic compound. All right. What is NH4? That's also a polyatomic ion. Is the only polyatomic ion that is positively charged. Ammonium. What is C2O4? Also a polyatomic ion. This is a little, and that is oxalate. Oxalate. So what I have 2 polyatomic ions in this problem. Ammonium oxalate. Okay. N2O4. Now, before you name N2O4, remember, before you name anything, decide, is it ionic, is it covalent, is it acid or basis? Because the naming would be different. The first one was ionic. The second one was also ionic. It was a balance of charges. You have polyatomic ions. It was ionic. Now this one, N2O4, is actually covalent, right? Why is it covalent? Because I have 2 nonmetals together. When you have 2 nonmetals together, that is covalent. Now, when you have a covalent compound, what do you have to use? You have to use the prefixes. You have to use the prefixes, right? So this would be dinitrogen pentoxide. Dinitrogen pentaoxide or pentoxide. I'm okay with either one. So this is a covalent compound because you have 2 nonmetals together. Before you name anything, decide what you have. Okay, H2S. What is this one? What is H2S? Before you name it, hopefully you go, oh, this is an acid. So you know the rules for the acid. These are the rules for the acid. So you go H2S. I have to see what is S. S is sulfur, but when you have an anion of that, it would be sulfide, right? Simple ions from the periodic table. When you have an anion, they just change the ending to ide, right? This is from a periodic table. The changing ends to ide. So if my changing is ide, I'm going to become hydro. So what is this one? This is hydrosulfuric acid. Again, because S is simple ion from the periodic table, is ide. Ide becomes hydrosulfuric acid. All right, good job for hanging in there. Next one is Cr. Cr is chromium. Cr is chromium. Okay. Now, what is NO3? Polyatomic ion. Hopefully you go, oh, I know that polyatomic ion is chromium nitrate. There's one part you should not forget, and that is chromium is a transition metal. So it has more than one possible charge. Which chromium are we talking here? Remember, nitrate, look at the polyatomic ion sheet, has a -1 charge. Where did the 3 come from? The 3 came from chromium. So is chromium 3 nitrate. Is chromium 3 nitrate. So far so good? Okay. Chromium 3 nitrate. Again, because this is a transition metal. Minus Ag and zinc, which have one possible charge. The rest you have to add a Roman numeral because they have many charges. And this is an ionic compound. So figure out what the compound is before naming it, because the naming will change. All right, last page, I think. Yeah. Let's do these ones. P2O4. Is it ionic acid or base? Acid starts with H. It's not an acid. Is it a base? No. Base ends with OH. Is it a metal and a non-metal? No. This is two non-metal together. So this is covalent. Decide what type of compound you have before naming it. If you have covalent, what do you use? You use prefixes. Okay? So, diphosphorus tetraoxide. Okay, I have to use tetra, I have to use prefixes, and the ending still ends up with "ide." The ending is still end up with "ide." You guys are good so far? Okay. So diphosphorus tetraoxide. Next one, I have a metal, I have a polyatomic ion, I have non-metals, metal and a non-metal, I have an ionic compound on hand. What is Fe? Fe is iron. What is SiO4? Hopefully you go SiO4 is a polyatomic ion. When I look at my list, is silicate. Iron silicate. One thing to think about. Iron is a transition metal, yes or no? Okay? If it is not silver or zinc, you have to tell me which iron we're talking about. Now, you know that the 4 came from SiO4 and the 3 has to come from iron, right? So is iron 3 silicate. This is why you don't have to memorize all the charges for transition metal, because somehow I have to give it to you. So the 3 had to come from iron. The 3 had to come from iron because you cross multiplying the charges. Yeah, beautiful. Next one. Okay, I go, next one starts with H. If you start with H, what are you? You are an acid. Okay, I know the rules for acid. Now let's look at this. What is this? PO3. It's a polyatomic ion. It's phosphite. It's a polyatomic ion. Phosphite. Okay? If you're ite, what does that mean? You're going to become us. If you're ite, you're going to become us. So what kind of acid is this? This is phosphorus. What am I doing? Phosphorus acid. Phosphorus. It has to end with us, because it was ite. Phosphorus acid. And it's acid because it starts with H. You guys are good so far? Okay. Last one, which is actually the hardest one, I think. I put the hardest one last. This is ionic. I have a metal and a non-metal. It's ionic. You're probably going to say, this is easy. Lead sulfide, because the ending has to be with ide. And I know lead could be +2 or +4. And it looks like lead is lead 2 phosphide. No, this is as tricky as a naming can get. Lead and tin, you have to be very, very careful because they have +2 or +4, and those are easy to simplify. So let's do this together. So PBS. Sulfur, I know, always has a charge of -2. That doesn't change based on the periodic table. Lead could be +2 or +4. You can probably see where I'm going with this. If I cross multiply the charges here, I get Pb2S2. Except, what do I need to do? I need to simplify. I need to simplify by dividing it by 2. I need to simplify. If you could simplify, you might simplify. If I simplify, I get PbS. Now let's look over here. This is cross multiply the charges. So what I get is Pb2S4. Again, can I simplify this? I could simplify this. If I simplify this, divided by 2, I get PbS2. Again, once you cross multiply the charges, if you could simplify, you must simplify. So be very careful with tin and sulfur because they have +2 or +4. Those are easy number to simplify. So which lead do we have here? Is it lead 2? Actually, no. This is lead 4. This is lead 4. This one is a little bit tricky. All right, beautiful. Now, I'm going to go back here for 1 second. Remember, before you name anything, figure out, is it ionic, covalent, acid, or bases? Ionic is easy. A metal and a non-metal. If you have that, balance the charges. Covalent, 2 non-metals together. There is no balancing of charges. And what you would have to use, you have to use the prefixes, right? We use the prefixes for covalent compound. And then acid. Acid starts with H, base ends with OH. And you still have to balance those. You still have to balance the charges for those. And you know the rules for acid. You know the rules for acid. And then you can just go from there. Nice job. We did a lot of practice problem. Go back, redo this. Make sure you get these down. I'm proud of you guys for hanging in there. I will talk to you guys next time. We're going to move on to the next chapter.